Hello, welcome to the session. In this session, we shall study about an important concept, that is modulus of a complex number. Modulus of a complex number. For a given complex number, for any complex number z of the form a plus ib, the modulus of z, the modulus of the complex number z is the non-negative real number, is the non-negative real number, which is the square root of a square plus b square, and is denoted by the symbol this one. And we call that the modulus of z. So this is the definition of the modulus of complex number z. So if you are given that the complex number z is equal to a plus ib, we define the modulus of z. We define the modulus of z to be the non-negative real number square root of a square plus b square. Right? So for a given complex number a plus ib, just will evaluate square root of a square plus b square. You know that square root has always two values, right? Plus value and minus value. That is positive value and negative value. And in this case, we will only consider positive value of the square root. That means we will take only positive square root of a square plus b square. For example, so if z is equal to say 2 plus I5, then so modulus of z is, so here, so given complex number is given to be 2 plus I5. It means in place of a we have 2 and in place of b we have 5. So modulus of z means what? It is the non-negative real number square root of a square plus b square. So a square means 2 square plus b square means 5 square. So square root of 2 square is 4, 5 square is 20. So it is square root of 29. Actually, square root has two values, but we consider only positive value of square root for the positive square. Right? Once again, in the definition, we will say this a non-negative real number. Because for a given complex number a plus ib, how we have defined modulus of z as square root of a square plus b square. In the complex number z is equal to a plus ib, a and b are real numbers. So whatever the value of a and b, a square is positive, or I can say non-negative, right? Because a could be 0 also. If a is 0, a square will be 0. So whatever the values of a and b, a square plus b square. A square and b square will be non-negative. That is, both a square will be greater than or equal to 0. B square will be greater than or equal to 0. So sum of two non-negative terms will also be non-negative. And square root of a non-negative real number is defined. Square root of a non-negative real number is defined. Hence, the square root exists. And square root of a non-negative real number is always a real number which has actually two values, positive value and negative value. Here we will only consider positive value, that is positive square. So positive square root of a non-negative real number is a non-negative real number. Hence,
For any complex number, the modulus of z is the non-negative real number square root of a square plus b square. And now the question is, for a given complex number, is the modulus is unique? Is the modulus unique? And the answer is true. Answer is yes, because for a given complex number a plus ib, what we have to calculate? Square root of a square plus b square. For a given complex number, a and b are fixed. A and b are fixed. A will be a fixed real number and b will be a fixed real number. So for corresponding to these two values, we can have one and only one positive square. We can have only one and only one value of square root of a square plus b square. So hence, under the definition of modulus of a complex number, what we are doing, every time I take a complex number and I calculate this number square root of a square plus b square, and I am observing that it is a unique number, because for a given complex number a plus ib, a and b are unique. A and b are unique. Square root of a square plus b square will also be unique. In the sense, any complex number can have one and only one modulus value. In this example, so for the complex number 2 plus 5i, the modulus is square root of 29. This complex number cannot have more than one modulus value. That means this z cannot have another modulus value other than square root of 29. So for a given complex number, its modulus is always unique. So what are we observing here? Every complex number. For every complex number, I can calculate this value, right? So for every complex number is associated with the unique real number. And whenever you come across the word unique association, so there comes the concept function. Function is nothing but unique association. You know that. Function means, so if you have two sets A and B, if you have to define a function from A to B, what you have to do? You have to associate every element of A to an element of B unique. So what we are doing? We are doing unique association. And wherever you come across this unique association, there enters the concept function, right? So here we are associating every complex number to a unique real number, so we have a function. Now we recognize that modulus of a complex number is a function. And what is the domain and codomain? Because you know that function or function, domain and codomain are mandatory. So what is domain? So the numbers which we start with. So those are complex numbers. So the domain is C and codomain, where these numbers are carried to real numbers, right? So it is R. So modulus of complex numbers is a function. It is a function from C to R, or you can say it is a real value function of defined on the set of all complex numbers. As the codomain is R, we will say it is a real value function, right? So it is a real value function defined by, how we are defining it? Every complex number A plus IB is mapped to the number, the non-negative real number a square plus b square. Or symbolically, if I take complex number A plus IB to be z, what will be square root of a square plus b square? It will be modulus of z. So I can represent this definition in terms of the function f from C to R defined by f of z equals z. It is a real value function defined on the set of all complex numbers. Modulus of complex numbers is a function, is a real value function defined on the set of all complex numbers. Now, whenever we come across a function, we can check it is 1 1 or onto 1 1 and 1. Now the question is, f is 1 1 or not? Is f is 1 1? So to say f is 1 1, what we have to verify? For any z1 and z2, for any two domain points, if the image is equal, that is, if f of z1 is equal to f of z2, then it must imply that z1 has to be equal to z, or diagrammatically, so 1 1 means none of the codomain element can have more than one pre-image. More than one pre-image. That means every codomain element should have one and only one pre-image. If it has two pre-images, what it will be? So if I say it is Z1, it is Z2. So f of z1 is this element, f of z2 is also this element. So f of z1 is equal to f of z2. But these two are distinct. If they are distinct, then it will not be 1 1 function, because f of z1 equals f of z2 has to imply z1 equals z2. So in simple words, I have to say that every codomain element should have only one. It cannot have more than one pre-image. If any one codomain element has more than one pre-image, then it will not be 1 1 function. Now to verify f is 1 1 or not, either you have to prove this. If you prove this, then f will be 1 1, or to disprove this, or to say that f is not 1 1, just you have to find a counter example. That is, just you have to find a codomain value which has more than one pre-image, and in this case we can find a very easy example, that is, consider the number square root of 2. So now square root of 2 is a real number, but it is an irrational number, so it is a real number. Now consider two complex numbers. One is 1 plus I and the other is 1 minus I. Consider these two complex numbers. So 1 plus I is one complex number, 1 minus I is another complex number. So what is, so if I take this as complex number z1, so take this as z1 and this as z. Then what is modulus of z1? It is square root of real part plus square of imaginary part. That is a square plus b square. So a is 1, so 1 square plus I into, there is nothing here, so I into 1. So b is also 1. So it is square root of 2. Similarly, what is modulus of z2? Modulus of z2 is square root of, once again, in place of a we have 1, so 1 square plus, and in place of b we have minus 1. Minus 1 whole square. Minus 1 whole square is again 1, so 1 plus 1 is 2. So what we have? We have two complex numbers having the same modulus value, or in terms of function if we see. So we have a function from C into R, right? Where every complex number a plus ib is carried to square root of a square plus b square. Now I am finding a codomain element, square root of 2, which has two pre-images. One is 1 plus I, the other is 1 minus I. So a codomain element, if a codomain element has two pre-images, then this function cannot be 1, or this condition gets disproved. You can observe here. So z1, take z1 to be this, z2 to be this. F of z1 is equal to f of z2. So f of z1 is its modulus, right? Root 2. Its modulus is also root 2. So f of z1 is equal to z2, but it is not implied that z1 equals z2 because it is 1 plus I, it is 1 minus I. These two complex numbers are not equal. So which fails this condition. So f is not 1. Now on. So the function is f from C to R a plus ib is carried to square root of
a square plus b square, or symbolically it is f of z equals z. So now we put that f is not 1.
now what about onto? Onto means every codomain element should have pre-image. Right? Every codomain element should have pre-image. Now, is that true? Is that true? By the definition of modulus function, the modulus of z is what? It is a non-negative real number. It is a non-negative real number. What about for negative real numbers? That means for any complex number, if you take any complex number and calculate its modulus value, it is always a non-negative real number, right? So, if you take any complex number and calculate its modulus value, what that means, it cannot be negative. It cannot be negative. So that means, so what is codomain? It is the whole real number system, and domain is C. So all the complex numbers. So if you see moduli of all complex numbers, they are all carried to only non-negative real numbers, right? So R plus means only positive reals, non-negative means you have to add 0 also, right? If we calculate modulus of any complex number, it is always a positive number or 0, non-negative. So for negative real numbers, so R means it has both positive real numbers, negative real numbers, and 0 also. Now, if you consider any negative real number, if you take modulus of any complex number, you cannot get a negative real number. That means, in other words, for a negative real number, there is no pre-image. Right? So, if I take minus, suppose minus. So there is no complex number whose modulus value is -2, right? Because modulus is always a non-negative real number. It cannot be negative. So there is no complex number whose image is -2. Hence, we found a codomain element which has no pre-image. So hence, not all elements of codomain has pre-image. So F cannot be onto also. F cannot be onto also. F is not onto. F is not onto. Hence, F is neither 1 1, not onto. Now, you know the notion of range. Range of a function means range of f is what? Range of f is the set of all images of elements of the domain. That is the set of all images of elements of the domain. And usually we denote it by f of domain, image of the domain. And what is this?
And can I say it is equal to r plus c and 0?
Right? Because first of all,
range of f is f of c. F of c is contained in r plus union
singleton set Z. Because so images, right? I am talking about f of C means what? It is the set of all images of elements of C. What is image of any element in C? It is modulus of Z. And what is modulus of Z? It is square root of A square plus B square. That means it is a non-negative real number. So for any complex number Z, its image is a non-negative real number. Right? So this whole set will be contained in this. And what about the converse? What about the converse? That means, can I say all non-negative real numbers are the elements of this set? This set only contains images of elements of C. It contains images of all complex numbers. Now, to say that this set is contained in this set, this set is contained in this set, so just you have to prove every real number. Every real number is an image of some complex number. Every non-negative real number is image of what? So to prove that this set is contained in this set, what you have to prove? An element of this set should be an element of this set. It should be an element of this set means it should be some image of a complex number. So if you consider a non-negative real number, x is a non-negative real number, then you have to show that x is image of some complex number. And what is image? It is modulus. And in this case, I can write it is the image of the complex number x square plus I into C, right? Because it is basically a complex number, because x is a real number. Basically, x square will also be a real number. It is of the form a plus ib with b equal to 0. That means it is a real number. That's it. And what is its image? Image will be modulus of that complex number. And what is that? It is square root of. So if I take x plus I0, so modulus of this complex number is x square plus 0 square. So square root of x square is x. Square root of x square is x. Hence, every non-negative real number is an image of some complex number. That means, so this is nothing but the range. So we got this. So range of f. It is f of C is R plus union the singletons is 0. And this set is nothing but the set of all non-negative real numbers. So this is the range of F. And you know that if you replace the codomain by the range of F, the function will be on. So hence, if I consider another function, so suppose F1 from C onto R plus union 0, the singleton set 0, the same definition, with the same definition. What I am doing is, just I am restricting the codomain. So what is codomain? Actually, codomain is R, just I am restricting it. That means, just I am neglecting the negative real numbers. Just I am taking positive real numbers along with the 0. So, restrict the codomain in this function from R to the set of all negative reals. Then it will be different function, just I have to name it, because f1 is not same as f, because its codomain is R, the other codomain is R plus union singleton set 0. But the definition is same. A plus ib goes to square root of a square plus b square. So if you replace codomain by the range of f, then the function will be on. This function will be on. But F from C to R with this definition is not on. So it is neither 1 nor onto function. So modulus
of complex number is
the non-negative real number square root of a square plus b square for the complex number that is equal to a plus ib. And we can recognize that it is a function from C to R with the definition f of z equals z bar. And we observe that it is neither 1 nor on. And the range of f is the set of all non-negative real numbers. So this is about modulus of complex numbers, and in the next session I'll come up with properties of the complex numbers. Thank you.